All right, so last time I taught this, I did it in a Discord call, and it was the like day it was due, which probably wasn't like super helpful to as many people as I would have liked it to be. So I'm just gonna record this early, and that way, people can get a broad overview and kind of hopefully have a better understanding of how they're actually supposed to go about coding it, before it's due. All right, let's get started. So before we actually do any solutions here, we're gonna look at the functions we need, because this project, in my opinion, is not really possible without having some helper functions. So the functions you're gonna want to have are insert a piece of candy, where you just give it like a bag, so like bag one, and then you give it like a piece of candy, like candy two. And then this will insert candy two into bag one. Very useful because it saves you a lot of coding. Generally speaking, in your other broader, harder problems. Remove is the same thing. So, one, two, remove from bag one, or remove candy two from bag one. All right. And then dump is just dumping a bag, right? So if your bag is full of like one, three, five, you just dump those out, get rid of it. We don't want it. Uh, Sort help. So you're going to be sorting your candy by quality. I'll get into this later, but you're going to need a helper function to sort it, since you're going to be using structs to do this. And then we're going to want to have a function to fill our bags, which just goes from our candy. So we're going to have oh, hopefully you would have a vector of like your candies. So starting at candy 0, going to candy 15, right? And what you would want to do is you'd want to have a function that just puts all of the candy into the as many like just put all your candy in order into the bags in order. That's what this does. Very useful function because it makes greedy and also a large portion of iterative very, 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 or much faster to code. Then last thing, you don't need it, but I put it in mine and I found it to help with debugging, which is print what's currently in the bags. You'd be surprised at how often the candy that you think is going into bags just isn't going into bags, or the candy that you like were like thought you were dumping out wasn't actually getting removed and it was messing with your program. All right. So useful-ish. The thing is, it is a little bit of extra coding to get it like up and running, but once it's up and running, it will save you time. All right, next thing we have candy struct. Candy struct should have a weight and a value at the absolute minimum. You can also put a location if you're that's what I did. So I have a weight value location. The other thing I did was put a quality in, which is a double. And this guy right here, what he does is he saves the value over the weight, which is very, very useful since the quality of a candy is how you do greedy. But we'll get into that in a second. In a bag, I just had storing a weight and a value. That's it. It just has the weight of the bag and the value of the bag. The other thing is that I had two other global variables that I thought were useful, which is total weight and total value. I found them nifty. Keep them if you want. It's the same thing as adding up all three bags. Speaking of, whenever you're making bags, I would highly, highly, highly advise, instead of having three variables called bag one, bag two, and bag three, instead of what you do is you just make or an array of three bags, like a three. So you'd have like bag for a bag struct, and then you'd have like bags as the name, and then in brackets three, right? We want to have three bags. That way you can do a for loop and you can be like for bags or for 0 to 3, uh, loop through the bags and you can just insert candies that way. It will be much faster. Like for example, fill bags is literally becomes two for loops if you do that. Uh, and so, useful function or useful idea in my opinion. So we'll put a little 3 after him. uh, just to know. You should have an array, not don't use a don't use three different bag objects. That would suck. That would suck a lot. All right, let's actually do some fake coding. Oh, all right. So putting candy into bags. All right, so here's where our helper function comes in. So you're definitely going to have your helper. So you just basically, this is so wonderful. So if you've done all my previous setting up, right? So if you have a fill bags function, a sort help function, and you've done like your bag array and stuff, you literally for this one, you just sort, right? And your sort help is going to sort your candy in order of quality, starting at the highest quality going down. So your highest quality is going to be about 2, and then the next guy's going to be like 1.9, and we go down. Um, so what sort does is he makes this a reality after we randomly input all of our candy. So you just sort your candy, and then you say fill bags, right? So basically, this is just going to go over all of your candy. So it's going to say, all right, put candy 1 in bag 1, put candy 2 in bag 1, and you try to put every piece of candy into bag 1, which if you have a working insert candy function, will just return I can't do it and not do anything if you like. So if you call insert candy on a piece of candy that's in a bag or like doesn't fit in the bag you're trying to insert it in, it just says no. Like the function just says no. And so you can just call fill bag and just say for every piece of candy, put it in every single bag. And then only the candy that fits will go in all your bags. So you'll say, all right, fill bags, and so that'll put candy 2, 1, or candy 1, 2, 3, maybe 7, because seven's like small. And then the next, and it'll go, all right, bag 2, put in, where did we start off? Or we leave off 4. All right, so put 4, 5, 6, 7's taken, 8, and then all right, then bag 3, and you put in like the rest of them, right? Very, very useful, and only the useless trash garbage candy down at the bottom, like I mean, it's the real bad stuff that no one likes, candy corn, stuff like that, doesn't actually get chosen. So all the useless garbage is just left out. And so that's how greedy filling of bags works. All right, and then after you call fill bags, you just print your total weight or print total value. My bad. Um, and that's the whole thing. Literally the whole thing. Not very hard. It's tricky to get the functions working, but once you have functions working, this takes 2 seconds to write. And that's what's so wonderful about it. Um, the other thing. Oh yeah, one other thing I wanted to mention is that uh, the location variable is very, very useful to have in your candy because that way you can like say if this candy is not equal, like so you'd have location 0 be bag 1, 1 be bag 2, and 2 be bag uh, 3 in your array, right? And then if you just set the whole thing to threes uh, for candy not in bags, and you can just say if candy.location equals 3, then it's available. Or it's nifty. I like having a location in. I found it to be quite helpful with determining where things are because if you store like the candy location in the bags themselves, you have to actually sift through your bags to find a piece of candy rather than just asking the piece of candy itself where it's located. Anyway, back to the actual function. Also, if you don't know how to make a helper function for sort, this is the C standard library sort where you just say, all right, sort from candy.begin to candy.end, and then you just put a comma, not a bracket. That's not supposed to be a bracket. All right, hold up. Let's make this a parenthesis. All right, the awful eraser. All right, bracket. All right, and then you say sort help, right? With no parentheses, just sort help, the word. Um, and I would advise Googling how to write this, because it's not complicated by any means, but I don't know how to explain it without a coding window. So yeah. All right, what's next? So this is how you do greedy. Very, very simple. This is by far and away the easiest. Actually, exhaustive isn't too hard if you get past. Anyway, we'll get to it. All right, that's exhaustive. This is iterative. All right, iterative is a little bit tricky. I found that this one had the most code in main, um, because it's not recursive or anything. You just iterate 1,000 times. All right, and so here's how iterative on a high level works, right? So you shuffle the candy and put it into bags. So randomly fill bags. This can be accomplished in a number of ways. I will go over a recommendation in a second. And then we also have what? Pick a random piece of candy. All right, so pick a piece of candy. Um, and then so this is just like pick candy in bag. Because if you pick a candy that's not in a bag, um, I'm realizing now that you probably could do that and just put it in a different bag. I didn't put that in my code, but like, it's too late now. I've already submitted and I'm done, so, whatever. But yeah, so just pick a candy, put it in a bag that it's not currently in. Um, and then, all right, so now you're probably gonna have this bag, right? And it's gonna be full of candy. And you're just gonna put in like this big chonker Snickers bar in there, and it's gonna want to explode, right? And all the candy's gonna fall out. You're gonna be sad. So the way we avoid this is by taking candy out after we put our new thick boy in. And you want to remove the most valuable stuff, right? We're taking out like the what's Three Musketeers. Three Musketeers are good. You're taking out your Mike and Ike's. You know, all the important candy really comes out of the bag. All the most valuable candy in the bag comes out of the bag until your bag won't explode. Right? No explosions. Bag's good. Bag won't hold. And now your bag has a Snickers bar in it. But it's probably going to have less value because you're not going to have your Three Musketeers. You're not going to have your Mike and Ike's. You're not going to have your Milk Duds. Milk Duds aren't actually that good in my opinion. But neither here nor there. All right, so now we have our Snickers bag and we've got this pile of candy next to it, right? Just like all of our taken out valuable candy. So what we do now is we just try to fill all of our bags with this new valuable candy. And if it fits, cool. If it doesn't fit, oh well, the solution's garbage. And then anyway, if it does actually fit, so if we give all of our bags, have some nice candies in them, they're all good, they're all kind of full, all your bad, awful candies not in them, then that means it's a good solution. And so we're going to just say, all right, this best sol is our current bags. And you don't actually have to store that. You can just store the value or the total value. All right, so you just store your total value. And now you have a current best solution. Just do that 1,000 times. So this like whole thing times 1,000. I think he told you that in the lab document though. And then, all right, so I said I'd go over something. Uh, Random filling, I think I said. Okay, so random filling, the way it's gonna work is it's actually fairly straightforward. So remember how we sorted the candy earlier? Yeah, so we're gonna unsort it. We're just gonna random shuffle it. So you just shuffle your candy around, and now your array is all like kind of really scuffed looking. But that's okay because we don't need it to look pretty because that's how iterative refinement works. So you now have a new random array of candy that's potentially better than your greedy solution. You fill it into your bags and then you swap some candy around. And if it's better, then you just keep it as your best solution. Simple as that, not too hard. Really, that's the high level. I'm trying to think if there's anything else. Oh yeah. So for picking the new bag that you're gonna put your like piece of candy that you took out in, I chose the current lightest bag. I feel like it might have helped a little bit just because like, if you put a candy that it's likely to fit in, you won't have to do as much removing. Oh, one other th yeah, yeah, another thing. Whenever you're inserting, right, you're probably gonna have your insert candy function. If you did it right, then your insert candy function is going to tell you no when you try to do this. So you're going to probably need to make an insert overflow function. This is because if you do it, in my opinion, the good way, then that means that your insert candy is going to be very, very good at like discerning where it belongs. And if it detects that it's like, hey, I'm not supposed to fit in here, I'm not going to go in. That's bad for this one specific purpose. Every other time it's useful. So make an insert overflow to alleviate this error very easily. Very straightforward to do. It's just like insert candy, but ignore all your parameters. Uh, Other than like if like basically this is just like insert but without a weight limit. You can so as long as the candy is just not in a different bag, insert it. That's kind of it. All right. I think that's pretty much all of it. Yeah, that's probably all of it. All right. Last thing. Exhaustive. So we have this new function here named check candy. Check candy is going to be a lot like check row and end queens. So basically, the whole way it works is you just for all your bags. So 4 times 3. Right. So or 4. I should say 1 to 3. So bags 1 to 3. We're just gonna insert candy, and then we're going to check row, or check candy, I guess. And then you're just gonna remove candy, and that's the whole thing. Um, However, this is gonna take a year. Also, you gotta have your base case, which is like if candy is like out of your vector, um, if your candy's out of bounds, right? Now we have reached a full solution. Um, and we can just say, all right, if it's better, so if better, then you replace the candy. That's not even a semblance of a word. All right, replace. All right, then also I forgot my F. So if better, then replace. Okay. Um, what else? Oh yeah. So there's not actually three cases. I lied. There's four. I tricked you. Okay, so there's four cases, there's three bags, and then also you got to check if there is not in bag, right? So we're gonna have like if 1 to 3, I'll make it a different color. So from 1 to 3, we do this. But for number 4, we just check the next candy. Uh, for case 4, you literally just check candy plus 1, right? So check the next candy. And those guys are separate. Um, And that way you won't like, yeah, no, check the candy in the bag for each bag and then check the candy out of the bag. All right, one last thing for exhaustive that this is all super, super simple. And you're probably like, wow, exhaustive isn't that hard. It's not. This runs in 30 seconds though, which is bad because, for full credit, you need zero point 0.5 seconds, which is very low. Um, so how do you do that? You do that with your secret sauce. Okay, so the secret sauce is an upper bound, and the idea behind it is that there is a solution that is currently the best. That best or if your current best possible solution, or upper bound is lower than your current, I guess, replacement guy. Uh, so if you have a variable called called best, right? This guy, he's got your best values in him. He's amazing, right? Super high quality. If the best possible thing you can do is worse than this, then you can just eliminate the whole rest of your tree, which will save you literally like a ton of time. It made my solution 60 times faster, I think. Yeah, 60 times faster. So worth implementing the secret sauce. This is probably just going to become in the form of check upper bound right here, just like a little check bound function. Uh, right, check bound right there. And then if your bound is if he's lower, so if best is greater than bound, then you just break or you return, because your current solution is useless and bad. Okay, what else do we have? Um, the other thing I wanted to mention about that is was there something else I wanted to mention? I think that's it. Oh yeah. That was annoying as hell to figure out, and I'm not about to just like explain how I did it, because it took me hours, and you know, what's life without a little bit of suffering, or as I like to call it, character building. Um, so yeah, that's how you do the whole thing. This is all the lab is. Um, and good luck to you all. All right.